Good morning, everybody. In fact, I need to start with an apologize because our president, Marco Cassis, was grounded by a flu, so he could not join us today for the keynote speech today. So I have the great pleasure to walk you through our presentation today for the topic Semiconductors Supporting the Evolution in Automotive. My name is Michael Anfang. I am in ST responsible for sales and marketing in EMEA. In our presentation today, we will give you a short, let's say, update on the automotive semiconductor market, complementing to that what was discussed before in an impressive way in the panels and in the Congress yesterday. And I will give you some insight how a semiconductor company like ST is supporting the megatrends which are driving the evolution in automotive. In general, we see two major megatrends for semiconductors in automotive. One is car electrification, the second one is car digitalization. So these two topics will be the focus of our presentation today. But before I go into this, please let me introduce quickly our company, ST Microelectronics, especially for those who are not so familiar who we are and what we do. We are one of the large global semiconductor suppliers, employing 46,000 people, and we generate a revenue well above $9.5 billion. We are an independent device manufacturer, which means we have our own manufacturing footprint with 11 manufacturing sites. Our customer base globally is very wide, more than 100,000, and we do 30% of our revenue in automotive. So this is a very important segment we are committed to, and we are serving since more than 30 years. So, how a leading semiconductor company is addressing the automotive? We approach the automotive market first by leveraging strongly our knowledge on automotive applications. To define and develop our products and technology, we work together with car makers, as well with tier ones and technology leaders, and more as well startup companies. We believe that the strategic foundation for an automotive committed company like ST is first to continue to invest heavily in technology development and product development, as well as manufacturing capabilities. And second, and this is very important, to drive innovative technologies which enable leading edge solutions. If you want disruptive solutions like silicon carbide, for example, I will go more in detail on that later, or domain processors. Third, very important for us is to build partnerships and relations. Specifically in Israel, we are very successful on that. I will show you also some examples later on that. And finally, we want to maintain our leadership for traditional applications, because we believe that also the car of the future will have airbags and car radios and comfort and body applications. At least I hope so. First, from personal perspective, because I like to drive my car and hear music, and second, also from business perspective, because from ST, we are, let's say, very much focused and successful on these standard applications, which we want to continue, of course, to support. Looking briefly to the overall automotive semiconductor market, the market is expected to grow compound over the next years in the range of 8%. Surely, this year for all of us in automotive is a tough year, but we are convinced on the midterm and the long term that the market will grow very positively. Why we are so positive? Because from a semiconductor company perspective, the automotive market growth is a story of car production growth, of course, but also a growth of semiconductor content per car. And if you see on the chart here, while the vehicle production is expected to grow moderately in the range of 2% in the next years, the semiconductor content growth is expected to be in the range of 5%. Important for a semiconductor company is, of course, to be in leadership position where the content growth is over proportional. If you look to a, let's say, typical automotive planning period of 5 years, for some of you this may sound strange and very long, but for semiconductors this is the horizon we need to plan, as well our capacity. The most of the growth potential is coming from car digitalization and car electrification, as you can see here on the slide. So let's look a bit closer to the field of car electrification and car digitalization. Starting with car electrification. No surprise, it's expected, of course, that the number of electric vehicles, cars, EVs, hybrids, will grow significantly over the coming years. And with that, we see a strong increase of semiconductor demand. Migrating, of course, from combustion engine to more electrified drivetrain. This migration, of course, we expect will be different in the different regions. While in China, for example, there's a very strong push directly to EVs. In Europe, we will see, or we expect to see, a strong content over the next years as well on hybrid vehicles, which is very important for us because the technology setup and the product solutions, what we need for that, are a bit different. On the left side, you see some examples of applications which are highly linked with the car electrification. Battery management, converters, chargers, and for semiconductor company, the most important one in terms of value, the traction inverter. And these new applications which are coming to the car and to the vehicles is resulting in a significant market growth in powertrain, as you can see on the right side of this chart, with 20% in average growth over the next years, more than doubling the market. So this is a great, let's say, potential, but also a challenge for us to support. One innovative technology I want to highlight in this field is silicon carbide for diodes and transistors. Silicon carbide is a very strong focus for ST because we believe is a real game changer in enabling higher power efficiency. And we see a strong, let's say, acceptance on the market of this new leading technology. We have more than 30 projects running in production already or prepared in production, also with car makers, as you can see here, some examples on the slide on the left side. And just to give you an impression how mature this technology meanwhile is, we expect that this year we will double our revenue to more than $200 million based on the silicon carbide technology. There is a strong investment still to be done on R&D, of course, but also on supply chain. Because SiC is a new material. So it's not only a challenge, let's say, of mastering the technology and developing the products, it's also to have the substrates which you need available for your production. And in that sense, for example, we recently announced that we will acquire 100% the Swedish company Norstel, which will increase our internal SiC substrate manufacturing capacity significantly. Of course, in car electrification, the opportunities for a semiconductor company is not only the silicon carbide. There's plenty of others. Just to name some of the examples, what we have here is, let's say, intelligent cell balancing for battery management systems, or the traditional IGBTs or high voltage MOSFETs. And very important low voltage MOSFETs, for example, as I said before, to support 48-volt mild hybrid solutions, which will grow strongly in the coming years. So we can say overall that the car electrification is representing a very strong potential for semiconductor companies. Important point is to build up the manufacturing capacity for that. If the growth is coming in the next 5 to 10 years, this will be a big challenge. In that sense, ST, being a leader in this field, we invest in the future. For example, with our new 300mm fab, what we are just having under construction in Italy, Agrate, close to Milan. Moving to the second megatrend, what we see, the car digitalization. This megatrend is not only but highly influenced by advanced driver assistance systems. We see on the market a very strong acceptance of ADAS systems. And as well here, we can see that semiconductor content growth is very strong coming with these applications in the car. If you speak about level 4 or even above autonomous cars, we speak even about $900 to $1,000 per car of semiconductor content. It's a very strong growth potential for us. And with this trend, we see that, let's say, the market is expected to grow well above $7 billion in ADAS, and as well for microcontrollers, dominated by 32-bit microcontrollers. So what are the key enabling semiconductor solutions in this interesting field? For sure, radar and vision processing. Second, connectivity, V2X, based on Wi-Fi and cellular. But as well as satellite-based positioning and, as I said, very powerful 32-bit microcontrollers and MPUs. And finally, functional safety and security as a kind of an integral element for all the solutions across the board. I have a couple of examples I want to show with you now. Speaking about vision processing, I want to highlight two main key programs what we have running. One is with Mobileye. It's a very important program. We have a very long, great relation with Mobileye, and it's a great honor for us to be, let's say, partner of the global leader in vision-based ADAS systems. And we developed since several years many generations of the IQ vision processor together with Mobileye. Currently, we developed the next generation, the IQ5, based on 7 nanometer FinFET technology. Very challenging and innovative program. The second one I want briefly to highlight is a cooperation we are running currently with Panasonic, is a development on a processing platform for advanced parking systems. And we contribute here with our experience on SoC integration as well as automotive grade development. This is one of the key elements what we as a semiconductor partner bring to these kind of important and complex programs. For connectivity, we partner as well with a great company from Israel, Automotive, leader in V2X, vehicle to car, car to car and vehicle to infrastructure communication. And we are the first one on the market with a dual mode solution supporting automotive Wi-Fi and as well 5G cellular connectivity. And we see on the market more and more requirements with respect also to ADAS system to have satellite-based positioning. And here our TCO family is, let's say, leading edge family, allowing well below 1 meter positioning, multi-constellation, ACLD solution. So it's a very interesting and innovative solution. A last area I want to highlight where semiconductor companies are contributing with a significant role to enable solutions is linked with the car architecture, the EE car architecture. With the immense increase of amount of data and connectivity, it is needed to re-engineer the car architecture. Let's say to go to a domain on an upper level domain architecture of the car. Otherwise, you would have to add plenty of other ECUs, while cars today have already 100 ECUs on board, so it's not possible. So we move more towards a domain architecture, let's say computers on wheels. And this requires new generations of microcontrollers and MPUs. Powerful multi-cores, virtualization, but still a good degree of real-time behavior. And one of the families we are offering here is the Stella family. We are sampling this with key customers, which is based on ARM, on the Cortex R52, and based on our 28 nanometer FD-SOI, embedding our phase change memory solution. Before I close our quick and brief introduction, I would like to highlight and thank some of our innovative partners we are working together here in Israel. You see the partners here on the slide. They are highly contributing to the transformation in the automotive industry. So to conclude, ST was always and is an automotive committed company. We are strongly investing in the megatrends, car electrification, car digitalizations. We are very proud about our partnership programs in Israel, and we are highly convinced on the innovation potential. And therefore, we have started a special initiative with the great support of the government here, which is called the ST Up program to support startup companies here in Tel Aviv. So I'm convinced with all the innovation spirit, what we have in the automotive value chain and what we see here on this Congress, that we will enable the mobility of the future. Thank you very much for your attention.